Hey guys, Travis Gillespie here. We're working with solutions to equations, and I'm using this box here because I'm going to create more of a visual problem to look at. So we're going to pretend that this box, there's a number inside of it, and we don't know what that number is, but we're intrigued. We want to know what's inside of it. It's kind of like getting a present early and wanting to open that present before you're really allowed to. So although I don't know what number is inside of this box, I do know if I were to add this to a number, so let's go ahead and get a number up on the screen. If I were to add it to, let's just say if I were to add it to 4, and I'm going to change colors here, and I'm going to put some integer chips on the screen, and I'm going to shade them in with blue. Now if you're using a pencil, you can use a circle with a plus sign for a positive number, but I'm going to use 4 positive integer chips. I have 1, 2, and 3, and then let's get a 4th one on here. So I know if I were to take 4 positive integer chips and add it to whatever value is inside of this box, well, I would get another number. I'm just going to change colors again, and that number would be equal to 7. But I'm going to use integer chips. I'm going to use 7 positive integer chips here. So I have 1, 2, 3, and 4, 5, 6, and a 7th one as well. So I have 7 positive integer chips. So when I add this value up with 4 positive integer chips, I get 7 positive integer chips. Now some of you might be able to calculate in your head what value actually goes in this box, but that's not my goal here. I want to show you another method of how I can get rid of some integer chips on this side of the equation and some integer chips on this side of the equation to find the missing value that goes in the box. In order to do that, I need to undo or get rid of some of these positive integer chips. So if I want to get rid of something, I'm going to do the opposite. If I have 4 positive integer chips here, I'm going to lay 4 negative integer chips down. So I'm going to put some red integer chips down below here, or these look like they're more pink than anything, but let's go ahead and just lay them down. I have 1, 2, 3, 4 negative integer chips. So I have 4 negative integer chips on this side of the equation. If I lay 4 negative integer chips down on this side of the equation, I have to be able to do the same to the other side. Another way of thinking about it is, whatever I do to this side of the equation, I have to do to the other. So let's put 4 more down on this side of the equation. 1, 2, 3, and 4. So now the equation's balanced again because I have 4 negative integer chips on this side, and I've balanced it by placing an additional 4 on the other side. So let's go ahead and I'm just going to box these chips up. Okay, and from here what I'm going to do is actually box these 4 integer chips up. I'm going to use pink still because I don't want to change colors. Since I have 4 positive integer chips and 4 negative integer chips on this side of the equation, I'm just going to cancel them out and just cross these boxes off. Now that I'm done with this side of the equation, I'm going to look at this stuff on the other side of the equation. Since I have 4 negative integer chips boxed up on this side of the equation, I'm going to also box up 4 positive integer chips on this side of the equation. And now they'll cancel each other out. Well, I'm left with this box with a question mark in it. Let's go ahead and just bring it down. And I'm going to put a question mark on the inside. Well, this is equal to, so I'm going to bring that equal sign down. This stuff that's left over on this side of the equation, so let's get that blue color again. I'm just going to place 3 positive integer chips down. So I can see that this box has 3 positive integer chips on the inside. Now in the future, I'm going to replace this box with a variable, and I'll replace the integer chips with numbers. I'll see you in another video.